Hello students, today we will see right hand thumb rule and the magnetic field, the pattern of a magnetic field which is produced around a current carrying loop. So let us see that. We have seen in the past that whenever electric current passes through the conductor, it produces a magnetic field around it. But what is the nature of the magnetic field which is produced around a current carrying straight conductor? We shall see. Now look at this circuit. This is the circuit in which there is a conductor, and you can see the conductor is connected to a cell or a battery, and the direction of the current is up. So the current is flowing in the upward direction. So it produces a magnetic field which is circular around the bar magnet. And if it is producing a magnetic field around a bar magnet, that means the magnetic field has a direction. So whenever a magnetic field is produced by a solenoid, or if it is produced by a bar magnet, or if it is produced by a current carrying straight conductor, the magnetic field always has a direction, and the direction of the magnetic field is related to the direction of current. So the direction of the magnetic field which is produced around the current carrying straight conductor can be found using right hand thumb rule. Once again I will repeat, the direction of the magnetic field which is produced around current carrying straight conductor can be found using right hand thumb rule. In this rule, we have to consider that the current carrying conductor is kept in the right hand and the thumb points in the direction of current. So here we can see that the direction of the current is up, so I am holding the pen in this time, so that means direction of the current is up. So we have to imagine that the conductor is held in a right hand and the thumb points in the direction of the current. So the curved fingers gives us the direction of the magnetic field. So you can see the direction of the magnetic field is this when the current goes up. Now applying the right hand thumb rule to this, when the direction of the current is exactly opposite, so what we have to do, we have to hold the conductor in a right hand and then align and stretch the thumb in the direction of the flow of current. So this is the direction of the flow of current. So this will be the direction of the magnetic field. So here we can say this is the direction of the magnetic field. My students, remember one thing, the direction of current which is taken into consideration is the conventional current that flows from the positive terminal of the battery to the negative terminal of the battery. So students, once again I will repeat that Fleming's right hand thumb rule can be used to find out the direction of the magnetic field produced around a current carrying straight conductor. Now let us imagine a loop. For example, I have a loop like this, a conductor like this. Imagine I have a conductor like this, okay, and the current is flowing in this conductor upwards. So if the current is flowing up, if I hold this conductor in my hand, what will be the direction of the magnetic field? Direction of the magnetic field will be like this. If I hold this conductor and the direction of the current in this conductor is down, if the direction of current is down, then if I hold this conductor in my right hand, the direction of the magnetic field will be like this. You can see here, direction of the magnetic field will be like this. So if I extend these conductors to form a loop like thing, you can see here, this is a loop, okay, and I have connected this loop to a battery loop. Okay, if I have connected this loop to a battery, we can see this is the direction of the current. The direction of current is up here and the direction of current is down here. So the magnetic field will be produced around this loop. And what will be the nature of the magnetic field? Here we can see, here if I apply the Fleming's right hand thumb rule here, then this is the direction of magnetic field here. What will be the direction of magnetic field here? If I hold it like this, this will be the direction of the magnetic field. Yes, like this. Okay, if I hold it here, what will be the direction of the magnetic field? What will be the direction of the magnetic field? Magnetic field will be going up and coming out. What will be the direction of magnetic field here? You can see here the direction of current coming like this and like this. So what we can see is, if you look, imagine this as a tunnel. The magnetic field is going inside. You can see here the magnetic field is going inside into the loop. If this is the direction of the magnetic, if this is the direction of current. So this is the nature of a magnetic field which is produced around a loop of a wire or a circular loop of a wire.